Have you ever just stopped and wondered, why are we here? I mean, really, why? It's one of the biggest questions you can ask, right? But the answer might actually be written into the very fabric of the cosmos. Today, we're going to dig into why our universe seems, well, so perfectly tailored for us.
All right, so let's get right into it. This whole puzzle has a name. It's called the fine-tuning problem, and it's pretty much what it sounds like. The fundamental laws and the basic constants of our universe, they all seem to be balanced on a razor's edge, creating conditions that are not too hot, not too cold, but just right for life to emerge.
And believe me, when we say fine-tuned, we really mean it. We're talking about the fundamental numbers that govern reality itself. If you were to just tweak them by even the smallest, most insignificant fraction, poof, the whole cosmic experiment just collapses. We simply wouldn't be here to wonder about it.
Let's take an example. The strong nuclear force. This is the stuff that literally holds the core of an atom together. Now, if you make it just a tiny bit weaker, you get a universe with only hydrogen. Nothing else. No stars, no planets, no us. Okay, so what if you make it a little stronger? Well then, all the hydrogen would have fused into heavier stuff right after the Big Bang. No water, and so no life. It's an absolutely mind-bogglingly delicate balance.
Or how about this number, 120? This has to do with something called the cosmological constant. You can think of it as the dark energy that's pushing our universe apart, making it expand. Here's the crazy part. Our best theories predict this value should be, well, 120 orders of magnitude bigger than what we actually see. That's a 1 followed by 120 zeros. It's such a massive mismatch that some have called it the single worst prediction in the entire history of physics.
And the so what of all this is profound. I mean, if that constant was anywhere close to what theory says it should be, the universe would have just ripped itself apart. It would have expanded so fast that galaxies, stars, planets, none of it would have ever had a chance to form. We'd be living in a cold, empty, totally sterile cosmos. Just nothing.
This whole situation just screams for an explanation. Is it all just a massive fluke, a deliberate feature, or something else entirely? Well, today, we're going to explore 3 of the leading ideas that try to answer this incredibly profound question. All right, our first explanation actually flips the question on its head. It suggests that our own existence is the most important clue we have. This is a concept known as the anthropic principle.
So what does that actually mean? Well, you can think of it as an observation selection effect. It's a bit of a mind bender, but the idea is, out of all the possible ways a universe could be, of course we find ourselves in one that's capable of creating us, because where else would we be? We couldn't exist in a universe that didn't allow for our existence.
Now, this idea actually comes in 2 main flavors. You've got the weak anthropic principle, which is pretty straightforward. It basically says, well, duh, of course the universe has the right conditions for us. We're here. It's just a statement of fact. But then you have the strong anthropic principle, and this one is much, much bolder. It claims the universe had to have properties that would eventually lead to life, like it was somehow built in from the start. As the famous physicist Roger Penrose puts it, it's really a matter of self-selection. We're only here to wonder why the universe is just right for us because, well, we can only exist in a universe that is just right. Okay, but for that strong version of the principle to be more than just, a philosophical shrug of the shoulders, it needs a real mechanism. And that's where the multiverse comes in. The absolutely wild idea that our universe isn't the only game in town. So the thinking goes like this. Imagine there are countless universes out there, maybe an infinite number, and each one gets its own random set of physical laws. Now, most of them are going to be duds, sterile, lifeless, boring. But with so many tickets in the cosmic lottery, a few are bound to hit the jackpot, right? They'll get the perfect settings for life to emerge. And our universe? It isn't special. It's just one of those lucky winners. And naturally, it's the only kind of universe we could ever find ourselves in. But what if it's not chance at all? A second, really provocative idea suggests that the emergence of complexity, and that includes life, isn't an accident, but an inevitable feature of the cosmos. This theory basically flips the script. It suggests that evolution isn't just a thing for biology, for plants and animals. No, it's a fundamental principle woven into the very fabric of reality. A law of nature that's constantly driving systems, both living and non-living, from simple arrangements to more and more complex ones.
The key concept here is something called functional information. Okay, what's that? Well, think about it like this. If you just mash a keyboard, you get a random jumble of letters. That's low functional information. It doesn't do anything.
but a specific sequence of letters, like the cat sat on the mat. Well, that performs a function. It conveys meaning. That's high functional information. This theory suggests the universe has a built-in bias. It favors the creation of these highly configured, high-information systems.
And if you look back, you can see this trend playing out all through cosmic history, right? The universe starts as this simple soup of particles, but it doesn't stay that way. It forms stars. Those stars cook up heavier elements. Those elements form complex minerals on planets. Then boom, life emerges, organizing matter in totally new ways, all the way up to us, with language and technology. The point of this theory is that this isn't just a string of lucky accidents. It's a fundamental law of nature and action. It's like there's an arrow of complexity, always pointing forward.
Okay, our third explanation takes this idea of evolution one giant leap further, applying Darwin's logic not just to life on Earth, but to entire universes. This is the theory of cosmological natural selection, sometimes called fecunded universes, and it was proposed by the physicist Lee Smolin. It suggests universes can actually reproduce, and there's a cosmic version of survival of the fittest. So how does this even work? Well, buckle up. The idea is that every single time a massive star collapses and forms a black hole, it doesn't just end there. It actually creates a brand new baby universe on the other side. And get this, the physical laws in that new universe are just slightly different, slightly mutated from its parent. So just like in biology, the universes that are best at reproducing, the ones that are best at making black holes, will have the most offspring. And over cosmic time, their genes, their physical laws, will become the most common.
And here's the kicker. This is the whole shebang right here. What kind of universe is really good at making a ton of black holes? Well, it's one that has lots of massive, long-lived stars and plenty of carbon to build them. And what kind of universe is good for life? One with lots of massive, long-lived stars and plenty of carbon. They're the same thing. In this view, we're not the point of it all. We're just a beautiful side effect of a universe that's optimized for making black holes.
Now, what gets physicists really excited about this idea is that, unlike the others, you can actually test it. It makes a real falsifiable prediction. See, Smolin's theory predicts that our universe's laws should be perfectly tuned for making black holes, and that puts a hard limit on how massive a neutron star can get. So if we ever find a neutron star that's heavier than that limit, about 2.5 times the mass of our sun, then the whole theory is in deep trouble. And that's what makes it real science.
So, we're left with this cosmic showdown. 3 powerful, totally competing ideas, all trying to explain our just right universe. Was it blind chance, a deep-seated inevitability, or the result of cosmic evolution?
So let's just lay it all out one more time. You've got the anthropic principle, saying we just won the cosmic lottery. Then there's this idea of a law of complexity, arguing we were basically inevitable. And finally, cosmic selection, which suggests we're just a happy byproduct of a universe that's really, really good at making black holes. Chance, necessity, or evolution?
So, which one is it? Are we just a lucky accident, an inevitable outcome of some deep law of nature, or are we just a beautiful side effect? For now, we just don't know. The answer is still out there, hiding in the deepest mysteries of the cosmos. But asking the question, well, that forces us to think about who we are and what our place is in this vast, incredible, and surprisingly just right universe.